Hello kids, let's learn the image formation in this case. In this case, the object is placed at focus. So keeping the object at focus, labeling the object as AB, the object position is at focus. Now we need two standard incident rays to obtain the image. So the first one is parallel to principal axis. We know that after reflection, it is going to pass from focus. Mark the arrow for the incident ray and for the reflected ray of light. The second standard incident ray that we know is a ray of light which passes from center of curvature of a mirror, of a concave mirror. It retraces its path. So you can see this is the ray of light which is passing from center of curvature and it is going along the same straight line path. So mark the arrow for the incident ray and mark the arrow for the reflected ray of light. Now, if you observe carefully, kids, the two reflected rays are this one and this one. So do you think that the two rays of light will ever intersect each other? They seems to be parallel. And if the two rays of light are parallel to each other, they're never going to intersect each other. But in reality, there is nothing which is 100% parallel. So we assume that here also the two reflected rays, they are not 100% parallel to each other. Somewhere at infinity, the distance between them is going to reduce, and because of which they will meet each other somewhere at infinity. So if they are going to meet somewhere at infinity, where the image will be formed? At infinity, because we are assuming that the rays of light, the reflected rays of light will be meeting at infinity. So the image position will be at infinity. What will be the nature of the image? Again, the nature of the image is going to be real as well as inverted. The image is formed in front of a mirror because of the two reflecting rays intersecting at infinity, thus it is real and inverted. What will be the size of the image? So if you see and compare the size of the image as compared to object, the size of the image which you will be obtaining at infinity will be highly enlarged. So the size will be highly enlarged. So we understand in this case that when the object is placed at the focus of a concave mirror, its real, inverted, and highly enlarged image is formed at infinity. Now, what is the use of this case? Are we using this case of a concave mirror anywhere in our daily life? Yes. The example which is seen in our daily life is in a searchlight, in a torchlight, and also in the headlights of a vehicle. So if you see a searchlight or a torchlight or a headlight of a vehicle, they have a typical same kind of a structure. There is a concave surface and there is a bulb. So if you see over here, there is a concave surface and there is this bulb which is being placed at the focus of the concave reflector. So when the bulb is placed at the focus of a concave reflector, what will happen? The light rays which are coming from focus will be striking a concave mirror. And you know that after reflection, all of them will become parallel to each other. So what happens when these reflected rays of light come out from a searchlight, from a torchlight, or from a headlight of a vehicle? These reflected rays of light are in front of you. And that is what you want. एक सर्च लाइट में आपको चाहिए कि उस सर्च लाइट से जो लाइट बाहर आ रही है वो सामने की तरफ दिखाई दे आपको, ताकि आप चीजों को आसानी से ढूंढ पाए. एक गाड़ी की हेडलाइट में अगर आप कॉन्केव रिफ्लेक्टर का यूज कर रहे हो, तो जो रिफ्लेक्टेड रेज ऑफ लाइट बाहर निकल कर आई विच आर पैरेलल टू ईच अदर, दे विल बी ऑन द रोड, दे विल बी गिविंग यू द क्लियर विजिबिलिटी ऑफ द रोड, एंड दैट इज व्हाट यू वांट. And thus, in a headlight, in a torchlight, or in a searchlight, the bulb is placed at a focus of a concave reflector, and this is how the rays get reflected after striking the mirror. I hope you have understood this image formation when the object is at focus, as well as the application of this case. Thank you so much for watching.